These little timers are great, right? Whether you're trying to study and you don't want to use your phone, or maybe you're doing something in the kitchen, they're a great option. But they could be so much more. Imagine you're doing something timed and you pull this out. It conveniently allows you to set a timer and beeps more and more as you run out of time. You would be more productive, your friends and family would be more terrified. I mean, this is a win-win product. Let's make it. Okay, so how do we actually make a scary bomb prop that functions as a useful timer? Well, a good bomb prop has two parts. First, you've got the explodey part, that's the technical term for the part that goes boom, and then you've got the control-y part, which decides when and how that thing goes boom. It also usually has a countdown timer and some increasingly intense beeping noises, but let's start with the explodey part. And right off the bat, I'm thinking dynamite. It's the most classic movie explosive, it's red, it's menacing. So the first thing I did was Google what the dimensions of dynamite are, and it looks like the most common size is 8 inches long and 1¼ inches in diameter. And we can actually get pretty close to that if we get some 1-inch PVC, which is of course 1 inch on the inside and about 1.3 inches on the outside. Once I secured the PVC, it was time to cut it down, which meant I had to decide what arrangement to go for, and there were so many good options. You've got the classic circle of 7, you've got the mini size triangle of 3, but I ended up picking the 5 stack as it seemed like a good balance between something you can handle easily and something that looks pretty menacing. Once I had the 5 pieces of PVC, it was time to decorate them. Now the thing about dynamite is it's actually wrapped in paper, so we can actually just use a regular sized sheet of paper and then paint that rather than having to paint the PVC. And these 8-inch sticks were actually perfect for a standard 8.5 by 11 piece of paper. I put the long side parallel to the PVC, glued it on, and then rolled it up, adding some more glue at the end to keep the edge down. Now for the ends, you just want to press the paper kind of down into the tube, and you do this from like 3 different angles, one after another, but if you do, it ends up looking pretty good. The main thing you want to watch out for is pushing the paper too hard, because if you go too far, then your dynamite will clearly be hollow, and that's not very scary at all. Once the dynamite was all wrapped up, I took it outside and painted it with some royal red spray paint. I also accidentally let it get rained on, but it turned out fine. You can see there's a little bit of variation in color, both from the rain and from, well, not that great spray painting, but it actually just looks kind of aged. At least that's what I'm gonna go with. I also tried to cut out a stencil and use black spray paint to put the word dynamite on there, but it didn't work very well. So if you can figure out a better way, let me know. But with the dynamite sticks complete, it was time to finish assembling the explodey part. And since there were some areas where paint had flaked off or where my atrocious attempt at putting words on had failed, I faced those areas into the center of the dynamite stack to hide all of my problems away. Then I took some 3/4 inch electrical tape and bundled it up with a strip at each end. And with the explodey part looking quite menacing, it was time to move on to the electronics. But before we do that, this video's sponsor, PCBWay, is having an amazing Christmas sale. You can check out the first link in the description. There's a whole bunch of discounts here and here and here, and if you scroll down a bit further, you'll find these little boxes you can open to get some free electronics as well. And they also have major discounts on their store. I mean, you can literally get this for 1 cent. If you like electronics or you want to get a PCB or a 3D print manufactured, check out the first link in the description, PCBWay.com. The sale ends December 31st. But now it's time to set up the electronics. The first thing we need is a nice red countdown timer. Then we'll also need a buzzer to make those beeping sounds to alert us that our food is cooked and stress out our friends. And we'll have to get an Arduino Nano to be the brain. And I'm thinking a rotary encoder to control the time. This little guy can basically rotate infinitely in either direction, and we can read that rotation, so it should be a good way to set the timer. It even has a button, so we could click that to start the timer once we've got it to the desired time. And the last things we'll need are a battery holder to hold a few AAAs and a switch so that the bomb can be turned on and off. Now I've gone ahead and prepared a schematic with all of this, so let's go ahead and check it out. Alright, here is our absolutely premium schematic. As you can see, real high production value stuff here. Starting with the batteries, you can see they're connected to ground and connected through this little switch here to V in. So this switch will control whether or not the Arduino Nano is receiving power. Then we've got this little buzzer here. You can see it's connected from A4 to ground. A4 is just being used as a digital pin here. Remember, you can use analog pins as digital, but you cannot use digital pins as analog. So literally, this buzzer is just going to be turning on and off And if we turn it on off for, a tenth of a second or a half of a second, that's a beep. Now, down at the center, we've got the main event, which is this display here. And you might wonder, how are we controlling 32 LEDs with just 12 cables? And the answer is something called multiplexing, which sounds scary, but it's actually pretty simple. So we've got these 4 wires here with squiggles on them. Each of those is a positive wire, and these squiggles just represent the fact that they're running through a 1 kilo ohm resistor, which keeps us from using too much current and frying either the LED or our board. But basically, each of these cables is the input for one of the digits. So imagine we turn off these 3 cables here and we just leave the orange one on. Now there's power going to all of these LEDs here, but the LEDs will only light up if the power is also able to flow out. So depending on which of the non-squiggle wires we have turned on or off, different ones of the LEDs will light up. And then we can turn this orange one off and turn this purple one on, and suddenly we're controlling the second digit. So basically we select which digit we're controlling by turning just one of the squiggle wires on, and we select which LEDs will be on versus off by controlling the non-squiggle wires. And last but not least, we have our rotary encoder, which of course needs power and ground lines. Then we have the switch pin, and then we have the data and the clock lines here at the top. Now in the real world, that ends up looking like this. Okay, it's a bit messier in the back, but we just have all of those connections that I showed you in the schematic made right here in the real world. And it looks pretty threatening, but not quite threatening enough. It's a little too clean and neat, if you ask me. To fix that, I have these. A bunch of random electronics ripped out of devices that don't work anymore. And we can just take components from these and stick them onto our bomb electronics setup to make it look a little bit more terrifying. A random inductor? Sure. A stray capacitor? Why not? Whatever this red thing is, definitely. I attached some of these with soldering, some with super glue, and some with electrical tape, all just to give it that assembled in a basement by a madman look. I also soldered on a few extra wires because I think in order to detonate the dynamite, there would have to be some wires going to the actual sticks. And once those were on, it was time for the final assembly. I put the electronics on the dynamite and ended up going for a third strip of electrical tape roughly centered to hold them on, and then I also kind of doubled over on the left side with some extra electrical tape, cutting out a little hole in it to make it fit, just to make sure those electronics stayed on. I also found out one of my wires was too short to get to the dynamite, so I just soldered it back on to the main electronics board. The other 2 wires, which if you notice they're nice and curly, that's because I actually just wrapped them around a pen and let them sit for a couple hours. I found little folds for them in the end of one of the dynamite sticks, so I squeezed some super glue into each of those folds and followed it up with the wire. Now all that was left was to add some batteries and enjoy them. Also, if you have any more ideas of what I should replace and what with, let me know.